We will, in this presentation, present our processes at Fundo Components AB in Charlottenberg, Sweden, producing chassis parts using tilt casting technology. We will show a top modern casting line that can fulfill the high demands of our automotive customers when it comes to quality, capability and efficiency. We will follow the process flow and production of a lower link arm, a chassis product for cars produced in high volume. To develop a casting line and dies, CAE and CAD tools are essential. Most important for us is the casting simulation tool, and we use MagnaSoft. This tool makes it possible for us, together with the customer, to adjust the product for the casting process. We can in advance predict where defects could occur and take measures to avoid them. We start the process in our melt shop, where we use induction melting and electrically heated holding furnaces. For this specific product, primary alloy aluminium silicon 9 magnesium is used. Chemical analysis is checked in our spectrometer before the melted metal is transported to the casting line. Gas impeller treatment is used to clean the melted metal from oxides and to assure correct hydrogen content. There are impellers in our melt shop and in combination with the furnaces at the casting lines. For chassis parts, to assure specific material properties, impeller treatment is a necessity. Density index check is made to check the hydrogen gas content in the metal after gas impeller treatment. The casting cell consists of a turntable with 3 casting machines, and each machine with 2 independent machine tables. 6 dies can be operated at the same time. The casting cell, including all robots, is fully automated. There are 2 holding furnaces at the casting line, which enables to do impeller treatment in one, while the other is in operation. The metal is poured into the die by a pouring robot. The casting process is called dynamic tilt casting, which means that the pouring robot pours the metal into the die while it's tilting, and the metal continuously will be poured into the die. The advantage with this method is that it reduces temperature losses. Metal velocity is low, which gives a laminar flow without turbulence, as turbulence gives internal defects. After pouring, the turntable turns 120 degrees and the next die comes in position for metal pouring. Complex casting line with 6 dies in operation requires capable and reliable process control systems for heating and cooling to assure the product quality. During the casting process, it's possible to stop the turntable. Take out a die to a server position for maintenance. After maintenance, the die is preheated, and when it's planned for it, will be taken into casting position again. At the same time, another die goes out for maintenance, and casting can continue without interruption. After solidification, the die comes into position for the extractor robot. The die opens, the parts are ejected from the die, the extractor robot picks the parts, immerse them into a water tank for cooling. Finally, they are placed on a pallet and transported to next operation. In this operation, ingate and feeders are taken away in by a saw. In this operation, holes are pre-machined before final machining. In this operation, final deburring of the outer shape is made by high-speed milling. The products come out on a conveyor from the casting cell, and a visual inspection is made. The products are now as cast, and the next operation is heat treatment. X-ray is a non-destructive equipment placed in the process flow and used to detect internal defects. Before heat treatment, the parts will be loaded into racks. For this product, T6 heat treatment is required. The heat treatment line is fully automated and every batch is fully documented regarding temperature, temperature curves and time. The heat treatment process steps is solution, water quenching and agening. After heat treatment process, the loaded racks come out by an automated carrier. The parts are unloaded from the rack and goes to Brunel hardness check. Quasar is a non-destructive resonance test equipment placed in the process flow and used to detect cracks, cold laps and internal defects. The bushing cell is a fully automated equipment for final machining, marking and assembly of bushings in the lower link arm. The process steps are dimensional check, machining, assembly of bushing with press force control, individual marking of the product, and finally visual inspection, including checking in a control gauge. Coordinate measuring machine, CMM, to be used according to control plan. Finally, a stiffness test is performed according to control plan. The lower link arm is now ready and will go directly into customers' car assembly plants.